Set my timer for 30 minutes here. So, good afternoon, everyone. I'm Jay Holzkamp. I'm with a company called Micron Technologies. I'd like to thank you all in advance for your time and attention as we go through this here. Before I start out, though, has anyone heard of Micron? You're not going to offend me if you haven't. A lot of people haven't. Thank you. A good mixed crowd. I say that at other venues. 2 people out of 20 will raise their hands, so we've got a much better ratio here. So thanks. For those of you who don't know who we are and what we'll do, I'll spend a few slides here just positioning Micron as a company. But the intent really is to go through and talk a little bit about where our technology fits into this Webscale architectures that you guys have been hearing about. And we got a booth out there, and I've been sitting here listening in on some of the other presentations, and I told Kimberly, my counterpart, that I want to see if we refute what they say or if what we say agrees with what they've been talking about. And the good news is it all agrees. We're all here talking about the next generation of technology, how to go from where we're at today as a customer base to take advantage of some of these new technologies. So what I've got is just 3 topics here. One is just a few slides on Micron. Again, this is just positioning so you know who we are and what we do. I want to address a couple of the top trends that are reshaping the industry. There's actually about 30 of them in this slide deck, but I've narrowed it down to really kind of focus in on some of the technologies like Flash that you've heard a lot about today, as well as Webscale. And then talk a little bit about the business proposition of Micron technology, because the installed correctly and architected correctly in a customer solution set, it actually pays for itself, which is something that most people don't attribute to Flash. And I've got a summary Q&A section that we can talk through here, but I like to keep this as interactive as we possibly can, so if you've got a question, raise your hand. So who is Micron? We are actually over 3/4 of the server value of servers that are being deployed right now in data centers. Our memory and storage solutions are OEM'd by many of the larger server manufacturers of the world, as well as many of the large storage vendors in the world. So if you don't know who we are or what we do, you're probably using our technology and don't even know about it in your data center right now. And that 3/4 is really composed of RAM being about 32% of the cost of a server. The cache SSDs, the solid-state devices that are used for cache, is another 1/4, and the SSD storage is about 20%. So that adds up to about 3/4, a little over 3/4 of the server bill of materials. We call them BOMs. The server BOM is based on Micron technology. So if you don't know who we are, you're probably using our technology now. Because of this capability that we have and the value that we bring to the servers, the world's largest Webscale companies actually use Micron technology. Amazon, Google, Alibaba, the rest of those are all utilizing our technology as an integral part of their Webscale services that they're offering out to the world right here. Facebook, Microsoft, the rest of them are out there. And the interesting thing is Gartner says that by 2017, these Webscale type of applications, the architecture of Webscale will actually be used in about 50% of the Fortune 500s. That being said, are you guys seeing that in your own customer base right now? Are you guys seeing that within your own company? Are you guys looking at non-traditional storage technologies to utilize, to replace SAN or to augment your SAN, your typical SAN deployments? Yes? Yeah, okay. Gardner's right, they nailed it, all right. So Micron is, we call this our countdown slide. There are only 4 NAND flash manufacturers in the whole world. Micron is one of those. There are only 3 DRAM manufacturers in the world. Micron is one of those. There are only 2 of those 2 companies, 2 of those 2 categories that actually manufacture both of those. Micron is one of that, and we are the only one that is US based. So the pedigree of the products, the integrity of those products are all based on technology that is US owned. This actually gets pretty important when you start talking to the US government and the DoD and the rest of that stuff, meaning the firmware that we write, the manufacture of these products is all based on US soil. We've got 13 fabrication facilities around the world. We've got 3 of them on US soil. The rest are deployed in the PAC Asia area. We've got 2 more coming online. Current technology is at 20 nanometer for anybody who's technical on that, but we're going down smaller and smaller. The interesting thing, and one of the reasons I joined Micron, by the way, and I used to work at EMC and Hitachi and Oracle and Sun and the rest of the cadre of large system manufacturers, is this technology that we're bringing to the market here that underlie these web scale type of architectures is really disruptive to the economics of a more traditional storage vendor. And that's what I've talked about earlier, that deployed correctly, this can actually help pay for itself without having to do any net new CapEx. So we are one of the largest manufacturers in the world right now. You know, one of the people were, I heard him talking earlier, our scientists actually know how many electrons, individual electrons, are on the gates of some of the semiconductor fabs that we're doing right now. At 20 nanometers, we've got plans that go much smaller than that. The issue becomes quantum mechanics at some point there. You start getting the wave nature of the electrons, and you lose the integrity of that gate structure, and then you lose that cell, you lose the cell, you lose the bit, you lose the bit, you lose the byte, and it kind of propagates up. So we've got some other technologies that we've introduced with Intel, where we are collaborating with them, called 3D Crosspoint, which allows us to get much better scaling, much denser types of products and technologies. What's on the roadmap today and what's on the truck to sell today is still some of the densest, most reliable flash products on the planet right now, and I'll talk a little bit about that. This is just orientation. It's not a product pitch, but this is what we do, right? We've got DRAM. A lot of people know us as a DRAM manufacturer on the left-hand side, but we also will sell silicon for other vendors, and we do that on a regular basis. But we've got networking solutions. We've got read and write-centric SSDs, along with PCIe SSDs that are out there, and MSATA drives and things like that. So when you think of Micron, just don't think of DRAM, think of the entire hardware product portfolio. And one of the things we have done to address, this is kind of interesting, I was talking to a customer and they were talking about solid state, and she goes, I hate solid state. I said, really, why? She goes, I never know when it's gonna fail. You know, if I hear a hard drive whining and crying, I know the bearings are gonna go bad, and I know it's gonna fail, I know I should really back up that drive. And I said, well, yeah, you're not gonna get any moving parts, certainly with flash. However, we do have Storage Executive, which is a piece of software that we wrote that runs on your servers. You can actually go out there and interrogate all of the flash, Micron flash that's in your storage arrays or in your enterprise, see exactly where you're at from a usage perspective, see how much capacity you have left, see how long, because we can predictive failure analysis, how long that flash is going to survive in a given market space. And I will point out something a little bit different too. I think about Micron as a company. We're obviously engineering led. We're very conservative. Our flash drives, our solid state drives, are actually rated in the data center. And that, one of the talks I wanted to talk about was the effective use of flash technology. You can go to CDW, you can go to almost anybody and buy a commercial grade flash drive. You can go home and put that in your Mac, you can go put that in your home PC or whatever the case might be, and you'll get really good usage out of that. You'll get good reliability because you as a consumer are not driving the amount of data flow that a typical data center would, where they have to address thousands to millions of users. So in an individual environment, in a consumer-grade product, the normal flash products, the low-cost flash products work great, and they'll provide you great service for years and years and years. If you took that technology and threw it in a data center, it will fail within months because the usage patterns of a typical data center memory storage is much different. So what we have done with our SSDs is we've got data grade, they're called DC, data center capable drives, and they come with 3-year warranties. We've got enough overcapacity built into these things to allow a full drive write every day, 7 days a week, 24 hours a day, and it'll last for 3 years. So the amount of data that can be dumped on these things actually can exceed the capabilities of a standard hard drive that's out there right now. So these customers that say, oh, you know, it's not as reliable, that might have been true years ago, and it might be true today if you take a commercial grade and put it in a data center. But if you buy the DC level drives, you're going to get much better performance and much better reliability than you would out of a standard rotating drive mechanism here. So that's just orientation, a little bit about some of the products here. Yeah?
What kind of failure rates do you see in enterprise SSD? Probably a lot less than anticipated.
Yeah, oh yes, it's much less than a typical rotating drive. The failures that I actually see are not failures of the drive. The failures become when, and this is going to sound apocryphal, but it's true, the failures become when the timers and then the mechanisms in the applications have certain expectations of responsiveness. If we can get that data back there really quickly, they can get into race conditions, and sometimes those applications will freeze up or fail. And when we take because we can go in there and take a look at the data sets, when we actually do the analysis of all that, it is typically not due to the flash mechanism failing itself. It's usually some other race condition that has occurred upstream. So we're getting much better at addressing those types of things by working with the software manufacturers that change some of their drivers to allow more responsiveness. It sounds counterintuitive, but sometimes, you know, if it takes too long, you're going to get a timer pop. Sometimes if you go too quick, the application isn't ready for that data and the buffers overflow. So to answer your question it is much more reliable than a spinning mechanism that's out there. The failure rates in data center drives, when they're installed correctly and utilized correctly, exceeds any type of solid state or any type of spinning mechanism that's out there. There's no physical rotations. So let me go through some of the top trends here. And like I said, there's about 30 of these, but I've winnowed it down to just a few for time here. I think you've seen this already here, but it bears repeating, I think. This third platform, this is, by the way, is from IDC. This third platform is underpinned by cloud, the cloud architectures that are being deployed both by customers and by public cloud companies. That underlying technology really is set up to address mobile, these devices. Everybody's got one of these things. This is a great generator of useless information for a lot of customers and a lot of companies. However, geopositioning, knowing where you are, being able to dynamically track your usage patterns on the web, and then correlate that to your spatial locations can allow advertisers and things like that to make you more custom bids to buy products and things like that. So these things generate an inordinate amount of information about the actual consumers that are out there. That all typically goes into this third platform where you have billions of users at any particular time and millions of applications. A traditional storage area array, and like I said, I worked at EMC Hitachi, it doesn't scale to that level. There's too many choke points to do that. So the industry has come out with this third platform, this third generation platform where you do scale out. You'll hear it called scale out or this third platform. The Micron technologies that we bring to market right now underlie and underpin this type of scaling and this ability to support billions of users that are out there. And IDC also says that arguably 90% of IT growth spending is going to be in this type of platform. So I asked earlier if you guys are starting to see non-traditional storage architectures enter into your enterprise. If you haven't yet, you will, because this economically makes a lot of sense to do it. It scales, it's less expensive, it provides more flexibility, it allows you to very easily expand by adding more and more server nodes that are out there. So one of the trends we see is, and this actually correlates very well with some of the discussions earlier today, software-defined everything. I mean, you've had virtualization, you've got software-defined data centers now. You certainly have software-defined storage. That is leading some of this third generation, the scale-out architectures. And what we see, and this next slide kind of shows it here, is a traditional enterprise SAN, at best over the next 10 years or so, is going to be slightly declining. So the investment in traditional storage architectures is going to be going down, and what's really going up at a compounded annual growth rate of over 17% is this third generation, this third platform, where we allow storage to be co-located with the compute resources. Instead of having a central repository for that storage with server nodes connected to it, we're actually taking and disaggregating that storage and putting that storage within the servers themselves. That makes a big difference for latency. You're not going through directors, you're not going through fiber channel arbitrated loop, you're not going through 10 gig E and the rest of the overhead associated with that. You're actually sitting there either on that PCI bus of that server or within the server itself as some type of solid state drive. That's going to be growing and continue to grow in importance as we scale up into these very, very large types of applications out here. One of the trends we see too, now you're going to say, oh yeah, well you make flash, so of course you're going to say this, but one of the trends we're really seeing right now is the rise of the solid state drives. People are getting very comfortable with this technology now. The price points have come down. The reliability, as I talked about earlier, has certainly risen. We've already solved through the inherent design of this product the latency issues and the rotational and I/O performance issues of a traditional spinning drive. We've got technology now called 3D NAND technology, and I'll talk about that, where we're stacking these chips on top of each other, and that's going to address the capacity issues. And we have already sampling 10 terabyte, 2.5-inch drives. If you think about that, that's really, really dense from a capacity perspective, which only then further makes the point that server-attached storage is going to be gaining a lot of momentum, continue to gain a lot of momentum in the market space here. You know, we're going to be able to get 10, 20, 30, 40 terabytes of storage in a 2U package. You know, you're already paying the compute resources for your application. You stick the storage in there. You can certainly amortize that cost of that server across the storage, so it actually pays for itself. You don't need the storage array anymore. You don't need that SAN, traditional SAN anymore. It's all being distributed within the compute factors that are out there right now. So on a cost per terabyte basis, the bottom bullet point here, in 2016, this upcoming year here, we're going to hit that inflection point where it will actually be less expensive to deploy flash in a server environment than it is to use some type of traditional storage mechanism with spinning drives or even hybrid drives. So that's how it can kind of pay for itself. I mentioned this earlier, but this 3D NAND technology that we have here is going to allow us to put 10 terabytes in a 2.5-inch form factor here. And you can think of it as a skyscraper. Each individual floor in this particular graphic here would be a traditional integrated circuit, a traditional flash set of cells. We're stacking them on top of each other to make this density. So it's really a way to hit parity on a cost basis with normal traditional storage arrays. The other trend we see quite often is reliability and data security. You know, nobody wants that CNN moment where they're going to have a camera shoved in their face with some type of security breach that's out there. Our drives, actually in the hardware controller itself, are OPAL compliant. So there's no overhead to crypt, there's no host overhead to crypt that information that's resident data at rest within that drive mechanism itself. It's a different part number you order off of the website. So, you know, Deltaware, if you have the need to have OPAL compliance, or if you're selling to financial markets or the government, FIPS compliance, you can actually order a part number. These products meet those requirements, so the data itself is crypted. We've also got something I think is interesting. You can actually, if you have an LSI controller and a traditional storage array, you can put our solid state drive in that shelf and it will register itself with that LSI controller. If anybody happens to break into your data center and physically pops that drive mech out and takes it home, and oh boy, they're going to steal somebody's social security number, they plug it into their mechanism, it's going to be locked out. They're not going to be able to see any of that information. They won't even be able to see that drive. So not only can we crypt at data at rest, we can actually lock that drive to that particular controller. So even if it's physically removed, you're not going to be able to read that data. That makes quite a bit of difference to highly sensitive government agencies, I'll put it that way, as well as some financial firms that are out there. So this data protection and the confidence of where this data is being held is a big trend for us right now. Do you guys see that right now? Are you guys having issues with data movement and data integrities and things like that with some of the customers or within your own company? Is that an issue? Yeah. Okay, good. The other thing that Flash certainly addresses is the responsiveness, the I/O capabilities, as well as a sustained throughput off of these drives is much better than you would get out of a traditional spinning disk drive out there right now. So your web applications or your database applications can get much, much better performance by utilizing Flash technologies. There's no rotational delays, there's no seek times, there's no data settling times, there's none of that. The data from the beginning of the flash drive to the end is all accessed at the same rate effectively, because we're not waiting for something to physically move around. So the responsiveness that we can actually offer out to those applications is much, much better. And it's something that customers are really, really working towards. I was talking to somebody earlier and said, people use mobile devices or they use the web. If something takes 2 seconds, they'll keep hitting the key. Like, oh, come on, 2 seconds isn't fast enough. So everybody's expecting very, very responsive response times out of their applications. This is a technology that actually can really help that by being deployed correctly and being put up at the cache level. One of the things I should point out too is our solid state drives are actually in a VMware environment. They're actually certified at the cache level, which speaks a lot to the reliability I talked about earlier and the endurance of these devices. So you can actually take in a VMware environment and put our solid states in the cache tier, as well as the main storage tier that's out there. And again, increased reliability because there are no moving parts, right? You don't have to worry about anything spinning and breaking. You don't have to worry about, as my customer said, I hate Flash because it doesn't make any noise when it fails. Well, you don't really have to worry about that anymore because of the reliability is actually exceeding what we can get out of hard drives. So let me talk a little bit about some of the business value by application. Specifically, I'm going to talk about virtualized environments, which kind of fits into the theme of what the other vendors have been talking about today and some of these other talks here. This shouldn't be a surprise. The hypervisors themselves need to be fed, right? The CPUs and the workflow that's going through those servers need to be fed. And if you get a pipeline stall within the CPU itself, your application responsiveness is going to suffer. As more and more P2Vs, physical to virtuals, occur, that workload is going up on these servers. It is more and more important to keep that data resident within the server itself. You can't afford latency. You certainly can't afford to have that data sitting out on some spinning mechanism somewhere else, or typically in a hybrid type of environment where there is some data on a spinning drive. You've cached that up through some type of software up into some type of flash on that array. That's good, but if the data isn't in that cache flash, you're still going to wait for that rotational delays. So it's really important to keep these hypervisors fed, and the technology and where we put flash in a typical environment really addresses this. It keeps that VM and that hypervisor working at peak efficiency. This graphic just kind of, again, sets the stage here. We've all done SAN flash right now where you've got your servers sitting up here connected to some type of fiber channel or Ethernet network through directors or what have you, typically in a SAN environment out to storage hard drives. Most customers now have moved into a hybrid flash system where they've got some flash sitting within their storage arrays right now. They've got some software that kind of manages usage patterns and it makes its best guess at what data you're going to want and prefetches that up into the solid state flash and then be able to present that back up to the servers that are out there. The next generation is these all-flash arrays. We've got solid fire here, but pure storage, the rest of these people. Effectively, what they've done is they've taken and got rid of hard drives entirely. Everything is sitting there in flash. That gives you better responsiveness to those applications, certainly, and it can give you better reliability and much better performance. What we are seeing in these large web scale applications, this third platform that I talked about, is really putting those SSDs right up in the servers themselves. And the technologies that we have certainly fit into the flash appliances, the all-flash arrays, the center of this slide. But we also fit up into that third generation where we're actually putting these devices up in the servers themselves, which further reduces latency. It further increases the overall performance because you're actually sitting on the bus structure of the server itself. And we've got proof points to talk a little bit about that as well. So this is taken from one of our customers here. They had a requirement, and it took 100 nodes for them to do this in their traditional implementation. Each node had 12 15K drives sitting out there. They were actually short-stroking those drives to do that. The hardware cost was about $1 million. It was like $980,000. We went out there and did some work with them and redeployed that storage, putting it into effectively 60 nodes. Because we reduced the latency, we increased the I/O capabilities, we kept that hypervisor busy, we could actually reduce the overall node count from 100, which what they had deployed, down to 60. That was a saving of about 40% on nodes, which is, if you look at the power, if you look at the tile floor space requirements, the rack space that was required to do that, we reduced our cost pretty dramatically. That actually funded 100% the cost of making this move for them. So when I mentioned earlier that done correctly, and if you take a look at the overall cost of storing a byte or a terabyte or a petabyte of storage, if you take that entire cost from the server all the way down to the spindle count, and then you deploy that dollar amount into flash and PCIe cards and put them up in the servers here, it'll pay for itself and you'll get better performance. And you'll end up saving a lot of money in the long term here. So these ROIs exist for financial institutions. We have them for manufacturers. People are moving into this type of architecture for the very reason it can save them hard-earned dollars right now. And the interesting thing too is if you look at a CapEx or an OpEx savings for these things, I've never had a VP of IT or even CIOs go, "Great, you saved me $400,000. I'm going to give this back to the CEO." They never do that. It never happens. What they do is say, "Great, you saved me $400,000. Now I can do the next project that wasn't budgeted. I can bring that forward in time from mid next year to this year now because I've got a hard savings in my budget to do that." So this actually enables not only better responsiveness for the customers that are out there, but it actually allows most of the customers to move projects forward in time because of the savings that are out there. This is another example. We took a VDI solution set here. This runs at about $42,000 on a per node basis, but when you divide it over the 800 VMs that are out there in a 4U server, we're running at about $200 per desktop. So that's highly competitive from a price perspective. The blue section of the pie chart here, by the way, is the Micron technology, a little self-centered here. But that also goes for remote office, back office solution sets. Typically, those are about $27,000. And by the way, the per node costs here are actually gathered from customers that are doing it. It's not made up by our marketing department. We actually went out there and polled a bunch of the customers, our robo customers, and this was the average that they were spending on a node by node basis for remote office, back office. Database was a little bit higher. That was about arguably $48,000 per node, but that's a 2 million transaction per minute infrastructure. So that's doing a fairly large OLTP type of an environment. And again, the blue is the technology that Micron addresses. Capacity solution, $2.25 per gigabyte out there right now. That's running about $60K per node. So these are real savings that customers are enjoying today by utilizing some of this technology and implementing some of this technology within their infrastructure right now. You know, and I can honestly say I've never had a customer say, okay, Jay, you've got this great solution set here. Can you show up here on Friday because by Monday we're going live? I mean, they never do that. What they will typically do is let the current infrastructure, as much as they possibly can, continue to run the business in a prod environment. They bring up the new architecture in a QA. They start migrating that data over, and then they'll do, typically a month or 2 months later, they'll do a cutover into the new architectures. There's a QA process they have to go through. Certainly we want to be able to characterize it. You know, selfishly for Micron, when we make these moves with these customers, we want to gather the before and after to make sure the customers understand the savings that they're actually realizing. So when we talk about these savings, they can actually see them hard. The only way you can do that is to get a true cost up front before you do the start here. So in these type of solution sets, we save these customers quite a bit of money. And again, they've never given it back to anybody. They always spend it on different projects. A slide here a little bit on the effects of cache. And again, this is in a hybrid vSAN type of an environment here. The blue line, the line going down here is a hybrid flash array. The green line going up is the all-flash arrays. And really what this shows in a nutshell is the scalability as database growth size along the x-axis here. As that increases here, we're actually getting, because you're adding nodes to the workflow here, you can actually get better performance on as the databases grow. Whereas a traditional hybrid storage array, because you're now exceeding the flash tier, you now are being throttled by the actual cost and speed of the actual hard drives that are out there. So we've got this, like I say, on all kinds of different workflows. This happens to be from one of the customers that we had on the financial market segment. I got a summary here real quick. Because people say, wow, why would I want to engage with Micron? You know, Kimberly and myself, Kimberly's in the back of the room here. We are actually field people. We're one of the few companies, DRAM manufacturers and flash manufacturers, that actually have a field force with engineers that are deployed throughout the country and around the world right now. We've done that, again, a little selfishly because we want to get our message out there. You know, through our OEM relationships, we are already solution sets for many customers, but they don't know we're inside. They don't know that we're the ones that are actually driving the bill of material costs for the servers that are out there. So we've ramped up our sales force and our engineering force to go out there and help spread the gospel, if you will, spread the messaging that's out there, and help these customers go from a traditional type of storage environment over into something that allows them to do web scale type of work here. You know, we're 35 years in history. We're actually 16 billion in sales, so we've been around for a long time. And we're the second largest storage company in the world right now. We've got a great partner ecosystem here set up. Deltaware is one of our valued customers. We also have relationships with Supermicro, HP, some of the others that you'll see up here, Pernex Data and the rest. So we've got a good, we think, a good complete solution set of technology products and integration partners that can actually bring these types of architectures out to the market space. More information, visit our booth out here. We'll be here for the duration of the day here. But just go to micron.com/storage. All the information you have out there, case studies are out there. We have a YouTube channel, and we're certainly on LinkedIn as well. So I would welcome you to stop by our booth here and also take a look at micron.com/storage. And with that, I will open it up for any types of questions. It was a lot of information I know that I just dumped on you guys here, certainly, but if there aren't any questions, I'd love to see you at our booth here, and we'll talk more one-on-one. Okay? Going once. Oh, it's gone. All right. Thanks, everybody.